Hi everyone, and thanks for tuning in to the makeup video for day 2 of the crisscross method, which, as a reminder, is the method that we use for finding the chemical formulas for ionic compounds. Today, of course, we started off with a do now, so please head to today's Schoology folder and complete that if you haven't already. The learning target for today is I can write chemical formulas for ionic compounds given the constituent cation and anion. We started off with the do now, we reviewed the crisscross method from yesterday, and then we reinforced some of the skills that we started building yesterday by playing an ionic formula dice game. Unfortunately, if you're tuning in from home, you won't be able to play the dice game with us, but I'll talk about what we did and give you an alternate assignment. So first, we reviewed by finding the chemical formula for an ionic compound containing both magnesium and bromine. So we're going to start by heading to the periodic table, finding magnesium. Magnesium is in group 2, and it's a metal, so it wants to get rid of those 2 valence electrons and take on a +2 charge. Bromine is a halogen in group 7A or 17, so it has 7 valence electrons and wants to gain an additional one to fill its octet. So bromine wants to take on a -1 charge. I'm going to crisscross these values after I erase the positive and negative charges. And my final chemical formula becomes Mg1Br2 as a result, but I can erase the 1 and have my final answer just be MgBr2 because the 1 is implied that there's 1 atom of magnesium per molecule of this compound. Like we already discussed, magnesium will be giving away these electrons, specifically 2 electrons from its valence shell, and Br will be receiving those electrons. Sorry, just spelled that wrong. And then think back to last week when we did the electron transfer diagrams between ions using the Lewis dot structures. Because today we're going to, after we predict the chemical formulas, refresh on this skill by creating the electron transfer diagrams. So to start these, we need to create the Lewis dot structures for every atom in our compound. Based on this chemical formula, I know that I'm going to have 1 atom of Mg and 2 atoms of Br. Heading back to my periodic table, I know that Mg, being in group 2, is going to have 2 valence electrons. So my Lewis dot structure is going to look like the chemical symbol with 2 dots around it. And each atom of Br bromine is going to have 7 valence electrons, counting across the groups 1, 2, 3, 4, 5, 6, 7. And I'm going to have 2 of these Lewis dot structures. 7 valence electrons for bromine and another 7 valence electrons for this bromine. Since magnesium, like we said, is the one that's giving away its electrons and it wants to give away 2, and each bromine wants to receive 1 to fill its octet, I can give each of these magnesium electrons to 1 of the bromine atoms. We then played our activity called Ionic Formula Dice. So each lab station was given a set of dice. One of the die had cations all over the 6 faces, and one of the die had anions on every face. And students would roll the combination of dice and get a random cation and a random anion, and then have to use the crisscross method to predict the chemical formula that would form an ionic compound between them. So, for example, If a student rolled CA, and let's say on the anion dice they rolled an F, first they would have to head to the periodic table and see that Ca calcium is going to take on a +2 charge by getting rid of its 2 valence electrons. And that fluorine is going to take on a -1 charge when it gains an electron to fill its octet. And then use the crisscross method. So Ca2+, F-, get rid of the positive and negative signs, crisscross. My final answer is CaF2. As you can see on the assignment that I've uploaded for you on ClassKick, if you were absent today, since we don't have any dice, unfortunately, that can be used online, I just gave you a random set of cations and anions in each row, and you'll have to create 7 chemical formulas from these random combinations using the crisscross method. There's not really room on this document to show your work, so don't feel the need to, but I would highly recommend just having a scratch paper or a piece of notebook paper nearby to make sure that you can do the crisscross method clearly. All right, and again, after the activity, we just kind of reviewed the crisscross method one more time and some important details about it. Firstly, that the charge on the atom or ion gives us information about the relative number of protons and electrons in an atom. So if I have more protons than electrons, I'm going to have an overall positive charge. And if I have more electrons than protons, I'm going to have an overall negative charge. The biggest mistake I've been seeing recently with students is putting the number of dots around their Lewis dot structure to be the charge value on the ion. But remember that Lewis dots actually represent the number of valence electrons in a neutral atom, which we get by counting the group numbers and skipping over the transition metals. Secondly, the subscripts on our chemical formulas do not tell us anything about the electronic structure on our atom. The subscripts on our chemical formulas tell us the number of atoms of a specific element per molecule of a compound. So this tells me that I have 2 atoms of bromine and 1 atom of calcium in a molecule of this compound. It does not tell me anything about the valence electrons or electronic structure. So for the independent practice for today, you have to do 2 things. After you complete the practice creating chemical formulas on the ionic dice page using the random ions given, there's a second page where you need to do 2 things. One, you will need to use the crisscross method and your periodic table to determine the chemical formula for the ionic compounds below. And then finally, you'll need to use that chemical formula to create and diagram representing the transfer of electrons between the metal and non-metal atoms using the Lewis dot structures. Please don't forget that you need to do both steps in order to get full credit. Thank you, and do not hesitate to reach out if you have any questions.